Okay, this is a walkthrough of how to do problems like in the 2D acceleration lab. Remember that now we've been dealing a lot with position versus time graphs that represent one-dimensional motion. This is a totally different thing. This is the path of an object as it moves through a two-dimensional motion. So let's say we have an object that's going through a path like this. It starts out on a curve like that, then it goes along a straight line for a while, and then it goes on a curve like that. And let's say that on this part of the motion, it's slowing down. On this part of the motion, it's speeding up. And on this part of the motion, it is staying at a constant speed. And we want to figure out what we can about the acceleration direction here, here, and here. Okay? Okay. I didn't say which direction it's going. You always need to know that. Let's say that it's going this way. Okay. So first, at this point, over here on the left, the velocity vector is tangent to the path, so there's the direction of the velocity. It's slowing down. So do you know, is the parallel part of the acceleration in the same direction of the velocity or the opposite direction? It's the opposite direction of the velocity. That's what happens when it's slowing down. So a parallel is that way. And now ask yourself, which way is it turning? Is it turning? Well, as long as it's not following a straight line, it's turning. And you can always think of fitting a circle to the curve at that point. And if you do that, it always points toward the center of the circle. Okay, so a perpendicular is this way. And so what's the direction of the total acceleration? Remember that it's what we're doing is adding the two parts of the acceleration without knowing the magnitudes of the two parts. So we know that the total acceleration is somewhere in between these two. So at this point, the acceleration has to be somewhere in that direction. Okay, now for that middle point. What do we know about that? Its velocity vector is this way. That's the direction it's moving. Is it speeding up or slowing down? It says it's speeding up at this point. So is a parallel in the same direction or opposite direction of the velocity? Speeding up means it's in the same direction. Whoops, let me use green again. Okay, so that's a parallel. Is it turning? No, in this case it's moving along a straight line, so it's not turning. That means there's no a perpendicular at all. And that means that the total acceleration, is just equal to the parallel part of the acceleration. So in this case, we actually know that the direction of the total acceleration is this way. There's no range. And that's because one of the two parts was equal to 0. Now let's go to the last one. The velocity vector is tangent to the path. Is it speeding up or slowing down? It's at a constant speed, so there's no a parallel in this case. The speed isn't changing. What's the direction of A perpendicular? Is it turning? Well, if you imagine fitting a circle, that's a pretty ugly circle, but you get the idea. A perpendicular always goes toward the center of that circle, and it's perpendicular to velocity. Okay, well, there's no A parallel, and total acceleration is just the sum of the two parts. So that says that the total acceleration, again, in this case, we know is in this direction. There's no range again. There's only a range of possible acceleration directions if both of these parts are non-zero.